Hey there! You ready to get your user interface mojo on? Because that's exactly what we're going to be doing in this video, and the next one. So far in this series, we made a new project, got it all set up with the enhanced input system, and then modified our player character to add some unique features. This time, we're going to deal with the HUD class and set up some widgets to display information from those player character things we created previously. And rather than just any old widgets, I'm going to walk you through the entire process for how to make your own, from a basic pen and paper design to how we put it together visually in the editor, tinker with the guts of it in C++, and do any final styling back in the editor again. Fair warning, it is going to be a long one, which is why I split it over 2 videos. So, once more my friends, let's get down to business. After you initially get used to all this stuff with the various Unreal classes, one of the questions that might come to mind is, what exactly is the purpose of the HUD class? I mean, the acronym HUD stands for Heads Up Display, and the term originates with the kind of visual displays integrated into the helmet visors of combat aircraft pilots. You know, the pilot could see how fast they're travelling and in what direction, no matter which direction they turn their head. These days, we'd probably call that augmented reality or something, but the idea has been around for decades. Anyway, the kind of user interface elements which provide supplemental data about what is happening in your game are arguably the same sort of thing. Data displayed in some way, drawn over the top of the actual view of your world. In this case, the view of the game world. Now, before we go on, I'm going to come right out and say it. You do not have to use a HUD class to display UI elements on the screen. The game mode needs one, but it will be perfectly happy with the default one, which doesn't actually do anything or show anything. And there's nothing really special about the HUD class which is used to make widgets work. You could decide to get your player character class to handle that if you wanted to. In fact, you don't need a player controller class either. You could handle everything we did in our player controller, again, all inside the player character class if you wanted to. But then you'd probably end up with a mass of code in the player character class all focused on doing different things, and eventually you'd probably start mixing it all together and it would end up a real mess. Okay then, so what will the HUD do? Our HUD class is going to be responsible for deciding what user interface elements to display on the screen at what time. In some games, the HUD can also be used by other parts of the game as a kind of a communication point for UI things. If things want to send data to update a particular HUD element, for example, they could just talk to the HUD and then the HUD could do the rest, routing the data to where it is needed. But if you remember last time when we made our player character, we added some delegates to it. So once we connect all that up to our widgets, we won't really need to do a lot of manual messing around to send data about. It should get handled automatically. We will set up our HUD to have what we're going to call different view modes so that the player can cycle between them. Let's get that HUD.bb.h file open and start by adding an enum to the top of it to represent these different view modes. Each view mode will determine exactly what is or isn't displayed on the player's screen, and maybe specifically how it is displayed. Let's add that to the HUD itself by giving it a new property of the type of the new enum we've made. The U property specifies edit anywhere, so if we want to change the default value from the editor, we could. We don't want blueprints messing with the value directly, but that's not really a problem here because the property is private, so we don't need to include a blueprint read-only specifier. In fact, if we try to, the Unreal tooling will probably complain. If a blueprint needs to change it for some reason, and I can't actually see why it would want to, we will add a function which allows it to do so in a controlled way, not only changing the value, but also calling any code which then needs to update the displayed widgets. We also need a function which our player controller can call when someone performs the input action we will set up for cycling through the different view modes. And in the CPP file, we can put in the basic implementation like this. So let's make sure everything still compiles and get the project open in the editor. We're going to need some way of the player changing which UI mode they want to use when they're playing the game. Now, in the majority of games where the UI doesn't really change that much while the player is playing, this would be handled as some kind of setting, something the player would select in a menu somewhere and that applies to the whole game. But what we're saying here for this particular example is the player can change this easily while they are actually playing the game, maybe to adjust for different objectives or play styles used to overcome certain things or whatever. It's a tutorial. So you should be getting used to this by now. We're going to add a new input that the player will use to cycle through those available modes. In Content, I go to the Input subfolder, create a new input action. This time, I name it Cycle UI Mode, and I leave the settings at the default, which is digital because it's going to be a button press. Then, just as we did before, we add a new mapping to our default mapping context, selecting the new input action and adding whatever actual inputs you want it to have. In my case, I'm using my Xbox controller's down D-pad button. With all that added and saved, you can close the editor again. Back in the IDE, I open the player controller bb.h file and add a new uInputAction property to it. I just copy and paste the SciBlast from last time and rename it Action Cycle UI Mode. We give this an actual value in the player controller bb blueprint class. I used a slightly different category on the property this time. It has its own little UI section. And there is one last little bit of code we need to add to the player controller to complete the picture. Do you remember? We need to add a new handler function to the .h file and then hook it up in the .cpp file. And while I'm in the header, because at some point we will want probably to reference the HUD, I'm going to add a new private property to store it in, just like we already have for the enhanced input and the player's character. So I call that player HUD. In the CPP, just like we did before, I copy-paste one of the sections which hooks up a handler to an input action and change it to fit our new one. All the handler function does for now is call that cycle to next UI mode method we put in the HUD class. So let's jump back to that. Now that we are going to do some nice UI stuff, it would be a real shame to go mess it all up with the same kind of on-screen debug messaging we used in the last episode. If you remember, last time I recommended UE log, so that's what we will use now. I'm going to put a UE log in the cycle to next view mode method. Using a static method of the UEnum class, we can get the text value associated with the current view mode, and we'll see that in the editor in the output log window. And if you're using Rider, you can also see the messages in the Unreal Editor log window. And if you're using Visual Studio, you can see it somewhere, probably. So, I'm going to test that everything compiles and then fire it all up. All the existing controls still work just as they did, because we didn't change anything. And when I click the down D-pad button, I can see the current UI view mode has changed. Clicking it a few times confirms that it does indeed cycle through the values just as I wanted it to. But how does it cycle those values, I hear you ask? If you look in the .cpp code for cycle to next view mode, you'll see that all I do is increment the current view mode value using the ++ operator, which might be a bit confusing because you would be well within your rights to say,
hey, you can't just ++ an enum, and even if you could, eventually it would overflow the available values.
And you'd be right. What I have done here is use a feature of C++ called operator overloading. Although you don't need to know about it right now, it is useful to know about because, well, it is a standard part of C++ programming, and as such, Epic do use it in the Unreal source code, and so I wanted to make you aware that it exists, in case you weren't already. Basically, C++ gives you the ability to provide functions for what happens when you use specific operators, the ++ operator in this case, on specific data types, the EHUD view mode in this case. And yes, that means you could add an F string and an F vector together using the plus operator, or test if a uStatic mash is greater than a F linear color, all stuff which sounds like total nonsense, and in those two examples it probably is. But what I'm saying is, if you had a legitimate reason to add two totally different data types together, and you knew how you wanted it to actually happen, you can provide a function to do so. In this case, I look to see if the EHUD view mode value is at the upper limit of the acceptable values, and if so, I set it back to the first acceptable value. Otherwise, I just add 1 to the uint8 value that it's based on and cast that back to the enum type. In this case, I prefer this approach to putting code to where the enum is actually used, which does a similar thing, because this way, anywhere the value is changed like this, it's going to do the same thing, and you're going to end up with cleaner looking code. And even though I don't intend to actually use it in this example, I also override the - operator. This is considered fairly standard good practice. If you override something, you generally also do it to the inverse operation too. Because let's face it, if somebody sees that ++ is implemented, they will tend to assume that - is as well. Anyhow, like I say, you don't need to become an expert on this. I just want you to be aware of it, because it's a feature that not all other programming languages have. I'll put a link in the video description to where you can find out more if you're interested. And of course, the specific code that does it in this case is in hudbb.h file, if you want to check it out. So let's make some widgets. Because we'll be making a few widgets that will work in a similar way, it might be a good idea to create a base class for them, so that it can contain anything which will be common to all of them. Before we start to do widgety stuff in C++, we're going to need to let the build tool know that we want to use the module in which widgety things live. That's the UMG module. And so the first thing to do is check the build CS and see if we have a dependency module names entry for it. We don't, and so I add it. I add a new Unreal class to the project, UWidget BB Base. That's right, it follows our amazing naming convention, one of the cornerstones of this project so far. In case you're new to the project or you forgot, the BB stands for building blocks, which is kind of what this series is about. I would take this opportunity to reassure the concerned individuals who have commented and are worried for the general health of my source code that I certainly would and do take a bit more care when naming things for real projects. And I guess a few people kind of missed that I was basically making fun of some of the naming standards you often see. In particular, all those silly pre and post fixes that people are adamant you need for assets in the editor, like blueprints. So please, it's okay. Take a deep breath, relax. Everything is gonna be alright. And because, like so many other people with a handful of videos on YouTube and over 10 subscribers who let it go to their head, I myself can start to believe that I am basically some kind of rock star. And as everybody knows, the best rock stars name their children things like Heavenly Hirani Tiger Lily or Moon Unit Zapper, which honestly sounds like a wonderful name for a Boolean, a term which incidentally came from a man called George Boole. I never met this guy, but it's a pretty damn good bet that he identified as binary. So, one thing I use a widget base class for is overriding anything which is editor specific. At the very least, that's the palette category, which controls the section of the toolbox that a user widget is placed in when you see it in the editor. By default, all your widgets end up stuffed together in a user created section near the bottom. Because I like to produce a lot of my work as plugins, I often prefer that the widgets are grouped by plugin name, but it could be anything else that you like. So, to make that happen, and also to introduce you to a very important feature of coding in Unreal, we need to override the GetPaletteCategory method of the UUserWidget class. And the code is very simple, but there is a bit of a trap involved. And it's my hope that if I take the time to explain it to you, it might help you avoid getting into problems at some point in your own projects. Now, if you already know about the various build configurations and optionally compiled code, you can skip over this bit about build configuration stuff. When you build your game, you might already be aware that there are some different settings you can use. These are broken into two main things, a configuration and a target. Configuration, by default, has debug, debug game, development, shipping, and test. And target has game, editor, client, and server. You can find out the specifics of these on the Unreal documentation website. I'll include a link again in the video description. You can see the current choices in your IDE, usually on a drop down somewhere on the main toolbar. Right now, mine is set to Development Editor, which is usually the default in your IDE. Which build configuration you use determines a lot of things about how the engine itself and your specific project will behave. When you build a shipping version of your game, a lot of stuff that might be useful for debugging is simply not included. It's completely ignored by the compiler, as are any code modules which specifically target the editor. That stuff is, generally, not required for the final shipping game. So by ignoring it, we get a build which is likely to be smaller and probably faster, which is what we want for the final game. If we're making a custom plugin that will provide new features used in the editor, then the code we write will be designed to work specifically in the editor. Now, the UUserWidget is one of the classes which needs to straddle the worlds of shipping build and a build which uses the editor. A user widget is used in the game, and so it is a shipping thing. But it is also used by the editor, and so there's some functionality which is needed there, which is not needed by the actual shipping game. I'll talk about modules in more detail in part 7, but for now, let's use our current situation as a good example. The UUserWidget class has a GetPaletteCategory method. So in our UWidget BB base class, I'm going to override that. Because I'm in Rider, I can use the lovely Generate Overriding Members utility to get a list of all the overridable members declared in the entire parent class chain. Super. In it goes an override declaration for GetPaletteCategory. The definition in the CPP file is simple enough. We can use the NSLockText macro to return an ftext which will be used by the editor to put our widgets under the subheading in the toolbox. I hit Ctrl B to rebuild the project. Everything builds fine, so I open the project in the editor, and once it's loaded, I'm going to package it. It ticks along for a bit, doing its build thing. and then it fails. It might not be immediately obvious why, because it gives the reason unknown error. But if you scroll up a little bit in the output log, you can see there was a problem trying to build UWidget BB-base. The error is UWidget BB-base getPaletteCategory. The method with override specifier override did not override any base class methods. Well, obviously that's just crazy talk. We know the method is on the base class. For one thing, Ryder told us so, but a quick check in the online docs also confirms it. Here's the link to the specific documentation entry. The problem is though, the compiler is right. Epic wrote the code in the UUserWidget class and its parent class UWidget, where the getPaletteCategory method is first defined, and they wrapped the method in both places in a conditional preprocessor block. Scary name, but it's not that complicated. What it basically means is when the compiler builds the project, it will look to see if there's a definition for something called with_editor. Only when there is, does it include the code inside that block. Depending which build configuration you've selected when you do your build will determine which Unreal specific definitions like this are set up. And if you didn't realize it already, when you package a game, you usually compile for a shipping build, although you can set it to anything you like. Bottom line, the getPaletteCategory method only exists on the UUserWidget class when you compile in a with editor build, and that means you should only ever try to override it in a with editor build yourself. The solution is actually very simple. You just do what Epic did. Surround your code for the override and its C++ implementation with editor blocks like they did. Just remember, you need to put it around the declaration in the header, the .h file, and the implementation in the .cpp file too. Now, the problem is you might not always realize this situation. The Unreal documentation has no specifier or flag on it to tell if something is easily an editor-only feature, and Ryder doesn't know that it should wrap the override with a with editor conditional block. At least till JetBrains probably will stumble onto this video and think, what an amazing upgrade to Ryder it would be. And then consequently they'll decide to shower me in their undying gratitude, possibly in the form of a couple of free subscriptions to Ryder that I could then shower you, the lovely subscribers, with. Anyway, unnecessary amount of showering going on there. Time to move on. So, for now, that override is the only thing our base widget class will have. Apart from using it as an excuse to tell you about the conditional compilation, there is other useful code that we might put in there, just not right now, and not for this tutorial. So let's get into the nitty-gritty of making widgets. If you're not interested in the design part, you can skip ahead. There are several different skill sets involved in the entire pipeline of making user interface elements. On your particular project, you might be responsible for more than one thing. You might be a solo developer working alone, or part of a tiny team, where each person may have responsibility for more than one skill set. If you are working as part of a larger setup, then it's likely there will be specific people responsible for each area. We're going to take a look at this as though it was a game project going through our fictional studio. I'm going to show you one possible UI creation pipeline, and it would be up to you to know who on your specific team would be responsible for handling each bit, or everything if you're a solo dev. If you recall, last time we rumoured that the lead game designer on our totally fictional and never in any way based on real experiences with actual real people in the real world, absolutely not, please believe that, team might get fired before this episode. And the studio directors are happy to report that they are providing him the freedom to find rewarding opportunities elsewhere. Quite honestly, the rest of the team is rather relieved about that too. No one really liked the direction he was taking the game in. Plus, there was the incident with the avocado in the staff kitchen at the Christmas party. But we deleted all the tweets and agreed no one would ever talk about it. The team was sat in their local pub discussing what to do next and how they really wished they could find an all-rounder, someone that understands graphic design as well as how development works. Miranda here was sitting in the next booth and she overheard the conversation and introduced herself. She studied art and illustration and was working for a web development company in the building next door to ours, where she ended up saddled with more project management than actual design work. And while she's never worked as a game designer, she spends most of her spare time growing her small but dedicated following on Twitch, where she streams gameplay from up-and-coming indie titles specifically, so she definitely knows her territory. Plus, she isn't currently on a government register distributed to all fruit and vegetable retailers, and that's good enough for us. Hired. So, after a day and a half getting settled in, the key players get together to discuss the game UI. Miranda has read the documentation, reviewed the concept art, and come up with the following rough ideas. So, the first thing presented is an overview of the general layout. It's not meant to represent the way anything will look specifically, it's just to show where each element will be and give an approximation of the relative sizes on a 1080p display. The research done before the project started indicated that this was the minimum resolution the kind of gamers playing our game are likely to want for performance reasons. Now, she has used a red dot to indicate how the individual elements would be anchored to the corners or sides of the screen, and in the case of the notification message text, how it should stretch to accommodate different screen width sizes. Additionally, she noted that no crosshair type thing was mentioned anywhere in the game design documentation. In her private life as an up-and-coming streamer, she recently reviewed a game that had archery in it and intentionally had no crosshair because the developers thought it would make things more immersive. The players didn't agree, however, and some even got around the omission by attaching a little bit of masking tape to their screen at the right place, making a mockery of the decision not to have a crosshair in the first place. The rest of the team agreed with the layout and also were surprised that no one before now had even mentioned a crosshair thing. Yes, our game should definitely have one, but maybe it will need to only appear under certain conditions and not others, hidden when we have character dialogue, for example. But we need to look at that separately. So, we are all agreed that we will have a crosshair, but right now we don't know what it should look like or when it would actually be visible. Health, Stamina and Psi Power bar. Two treatments are shown for the HSP bar, a full-size, standardized version displaying the bars themselves, each with an icon depicting what the bar represents, and the actual value displayed numerically at the bottom, and a mini version where only the icons and the values are shown. Character action icons. This widget shows which movement mode the player is in when not simply walking. When crouched, an icon will indicate this, and similarly, if the player toggles run mode, then a different icon is shown. Both these things are directly connected to stamina consumption and regeneration, so the widget will also display if the player attempts to perform an action which fails due to not having enough stamina currently. For the notification messages, there isn't really much to say about this at this stage. It's highlighted again that however it's done, it should support different language choices, and that messages will appear on screen, stay for a limited time, and then vanish. If other messages arrive while one is currently being displayed, then they will be stored and displayed later. Our lead dev says that's called a queue. Good for him. The keys widget will display the number of keys the player is currently carrying. In addition to that, it can also display another forbidden style symbol if the player enters an area that's locked and they do not have the appropriate key. So what comes next? Well, the next step depends entirely on you, on your team, and how it's been decided people will work. Some people like to make more detailed drawings as the next stage, and for complex designs this can be useful. Other people prefer to make prototypes directly from those wireframe drafts we have already seen. It depends on your team and how you prefer to work. It may also depend on the specific element being worked on. For example, drawing 3 simple coloured bars representing percentages for health, stamina and psi power in a widget is fairly easy with simple rectangular shapes. But what if you're making a Celtic themed game and the chosen design had woven the bars over and under each other? If you think about that for a moment, you'll realise it's not quite as obvious how you would make such a thing, as it just isn't possible to have single widget elements go over and under another one. So it might take a bit more thought about how you could actually achieve that. And yes, I know a lot of people are keen to get stuck in, and there's often an opinion that a lot of documentation is a complete waste of time, and truthfully, I can sometimes agree, some of it is. However, sometimes it's not only useful to have documentation, but the processes used to create it can help you arrive at better solutions and realise problems before you hit them in code. Anyway, let's get back to the project and our widgets. Each widget will have a C++ base class derived from the one we already made, where any logic happens, and then a blueprint derived class, which is where any layout for visual things like animations are created. I often find it's easier to create the blueprint first, as it helps me decide what I will need in the C++, but you can go about it in any order you like. And remember, you can always reparent a blueprint after you create it, so that it derives from a different class. And that's exactly what we're going to do here. We initially create a blueprint derived from UUserWidget, and later we will change it to the C++ class that we're going to make. It's not complicated, I'll show you how that happens. So, I make the new widget blueprint in the Unreal Editor content browser. Under the content folder, I have a UI folder, and in there, I right-click, I choose User Interface, Widget Blueprint. When we make blueprint widgets, they're generally going to derive from UUserWidget or a class which inherits from UUserWidget. Our base class for all widgets would seem like the obvious choice to select here, but as I just mentioned, because we're going to be reparenting it later anyway, it really doesn't matter right now. To that end, I'm just going to click UserWidget at the top of the pick parent class request window and then give a name to the new widget blueprint. This is going to be the class used for the HSP bars, all three bars together. So I'm going to call it HSP bars standard. I add the standard to the name because it's totally possible that a game designer or UI designer or any other bod with the word designer in their job title is going to want to change things, and we might end up with several versions of basically the same thing, but I'm getting ahead of myself. After naming it, I can double click the new widget blueprint to open it in the editor. The widget editor. In case you are not familiar with the widget designer, let's take a moment to look at it. Obviously, I'll be talking about where you usually find things in the default layout. If you've changed the layout on your PC, then you ought to know where they are in your setup. This area, by default on the left, called the palette, contains the widgets which you can combine to make your own widget. Also on the left beneath that is the hierarchy view, which will contain a tree structure showing how all the widgets used are nested inside each other. And it also gives you a way of selecting any widget, even if you can't actually click on it in the main view, because maybe it's too small or it's obscured by another widget or whatever. So of course that brings us to the main view where we get to see the widgets we use and how they look when we change their properties. Ideally, this will be pretty much how they will look when we're running the game, but be aware that some widgets either don't update directly in the editor the same way as they do when running the game, or perhaps they can't because maybe they rely on something that only exists when the game is running. Good widget designers making publicly saleable widgets, the sort of thing you expect if you purchased something from the marketplace, will take great pains to ensure that the widget in the editor does its best to represent how it will look when running. But many free projects you might download from GitHub won't bother at all. Depending on what the widget will do at runtime, the designer might have felt it just wasn't worth writing a whole bunch of extra code just to make it play nicer in the editor. So just be aware of that. On the right hand side, we have the properties panel, in which you can view and set the various properties for the currently selected widget. In the top right, you can see what class this widget derives from. Here you can see we based it on UUserWidget. And just below that, there are two buttons to switch between the designer view, which we're in now, and the node graph view, which you will already be familiar with if you are a blueprint coder. If you click on that graph button, we get a fairly familiar site for blueprinters, but we're not really interested in any of that right now, except to point out one thing. In the main toolbar at the top, the Class Defaults button is currently selected. If you click on the Class Settings button next to it, the properties shown in the Details panel on the right change, and this is where we will reparent our widget to a different class later on, selecting the new class from the Parent Class drop-down you see here at the top. Great, so that's the broad strokes. If you're making a widget, which is basically just a specialization of one existing widget, for example, some text with specific colors, a font, a setting, something like that, or a button which will work in a specific manner, then you can just drag the widget you want to use either directly onto the main edit area or into the hierarchy. Remember, your blueprint widget is actually a tree structure made up of other widgets. So depending which widget you add as the root of the tree will determine if you can even add other widgets to it. What do I mean by that? Well, if you'd chosen a text block widget and dragged it as the first widget into your design, well, that's going to basically be it, because the text widget does not support containing other widgets. And honestly, it wouldn't really make much sense if it did. If you had chosen to make a specialist button though, then you can add other widgets into the button, because a button is also a container. Why is a button a container? Well, because it makes sense. You might want a button to contain an icon and some text, or even something else. So, some widgets, like the button, can contain other widgets. It is a button. It does buttony things like showing different states when you mouse over it and click it and all that buttonish stuff, but it can also contain other widgets. However, there are specific widgets whose only purpose in life is to contain other widgets. Now, you don't normally see those widgets at runtime, you just see the widgets they contain. Most of these can be found in the panel category of the widget palette. They're useful for achieving specific layouts. The most commonly used, in my opinion, are the canvas panel, which is often considered a general purpose container. You can lay the contained widgets out with specific offsets and anchor them to the sides or the center of the canvas and have them stretched if the canvas should change size. There's the grid panel, which lets you define a number of rows and columns, and then widgets placed into it can be located into the specific cells or stretched across or down multiple cells, which is great for things which need to be laid out like a table. And you have the horizontal and vertical box containers, which both work in the same way, just in different directions. They allow you to add a number of widgets and the container will place them next to each other in the specified order, which is great for toolbars or stacks of status icons, that kind of thing. Then you've got some slightly more specialist ones, like the uniform grid panel and the wrap box. You might use a uniform grid panel for something like a keyboard, keypad, or numeric entry button widget, where you want all the contained widgets to get exactly the same space. Wrap box, on the other hand, will position new widgets left to right until you reach the side of the available space, and then it will wrap to the next line. You might use something like that for some kind of inventory display. The point is, there are not exact hard and fast rules here. Try to familiarize yourself with the different types of widget available, especially the panels, and then you'll have a better idea of how you might be able to achieve a specific UI design that you need to make. So in this case, what are we going to use? Well, we will have 3 separate vertical bars. We could, for instance, do that with a grid panel having 3 columns and 1 row, or 3 columns and 3 rows, because we know there'll be icons at the top and values at the bottom. We could use a horizontal box where we add 3 bars side by side, and those bars are other widgets themselves containing more widgets. We could use a canvas panel where we place our bars anchored to the left, right, and center, and then size them how we want. And there are many other ways to do it too. Obviously, some of these techniques are better than others, and some of them downright suck, because they're harder to work with and they're less flexible if we want to make any changes. So, let's consider a more realistic process now. We started making our widget, it's open in the editor, and then we look at the design, and the first thing that stands out, we're dealing with 3 basically identical bars. We know they have different icons, different values, and different colors, but they will all work in the same way. Okay then, so instead of making a single widget with everything stuffed into it, we choose to actually make a widget representing a single bar and then use that 3 times in our HSP bar widget. No problem. Let's make another widget blueprint to represent a single bar. I'll repeat what I did with the first widget and call this one StatBar. Okay, now we're getting somewhere. A single bar that's simpler to understand. So what do we need here? Well, we got a number of things stacked on top of each other, which kind of sounds like the vertical box. So I'll start with one of those. Starting from the top, I'll then add an image, which will hold the icon, 2 border widgets, which will represent the filled and empty portions of the bar, and a text block widget, which will hold the value. I add all those things, and then I play a little with the brush color of the 2 border widgets, just so they look different and I can see what's going on. It won't be used at runtime. It seems if we set those borders to fill, then they both occupy all the available space. And there is a float shown in size where we can control how the available space is divided up between them, which looks kind of like what we want for a bar. Okay, I'm going to select a temporary image for the icon. Under brush, I use the image drop-down, and I select analog hat from the engine files. It looks like a kind of a red bullseye targety type thing. Now, we can see that the image is stretched, and we don't want that. So I go to the slot properties at the top and set both horizontal and vertical alignment to center the image. That's better, because nobody wants a stretched slot. This temporary image we're using is 32 by 32 pixels, which is a bit small. I'm sure we'll get something better from the art department. So I manually set the image size to be 128 by 128, and that layout is starting to look a bit closer to what we want. We know the text will be 3 or 4 digits wide, so let's put that in so we can see what it looks like. Okay, this basic setup is looking more like what we're after. I hit Save All, jump back to the main HSP bar standard widget. So the root widget will be a horizontal bar, and to that I'll add 3 of the new StatBar widgets. I set the size of all of them to fill and make sure the alignment is stretch in both directions. A little more practice resizing to see what it looks like. Yeah, that's okay, but they're touching.
No touching.
So I select them all and set the padding to 5. That adds some spacing around each of them. You've got fine-grained control here. You can add the padding to specific sides of each widget to get the precise layout you want, without adding it to the top and bottom as well like I just did. So let's not be lazy and actually go in and do that individually, just to get exactly what we like. Alright, now the design calls for some color behind all the widgets in the bar stack. So, back in the StatBar widget, I select our root widget, which is currently the vertical box, and I right click and wrap that in a border. I tweak the border to get some visual idea of what I want, giving it a slightly transparent color so I can see the contained widgets properly. Now, I'm a little concerned that if we change the size of the widget, I also want it to look nice, in regards of both the icon and the text. If we make it bigger or smaller, the text ought to scale, and the widget too. So I right click on the image and select Wrap with Scale box. I want the image sized so that it fits the width of the bar, so I set Stretch to Scale to Fit X. With the text, it's a little bit different. I still want the scale box to size the text, but this time I want to give the scale box a dedicated percentage of the total available space, meaning that the longer we stretch the bar, the more space it will have. It's actually simple. I set the text scale box to also be fill, so now it's sharing the available space with the bars. I give it 0.05 size, and leave the bars at 1.0 size, and set the scale box to Scale to Fit. I grab the resize arrows from the bottom right of the widget and start stretching it around to see how it will respond to different sizing. Well, it isn't perfect, that's for sure, but I have already made this a little more complicated than perhaps I should by including the scale boxes anyway, so let's leave it at that for now. We're spending a lot of time trying to go over little details here so that you can understand the process, but with the best will in the world, there are going to be some subtle property settings which I'm not going to mention and which do make a difference. As usual, the entire project and its source code will be available on GitHub with the link in the description of this video. That's really the best way to know what's going on. Load it up yourself and investigate. And of course, remember our Discord server if you have questions or would like to chat about anything game dev related. Okay, so save all that and jump back to the HSP bars widget again and play with the resizing one more time. Pretty comfortable with all that, so let's go with that as the layout for now. So, back in StatBar, I'm going to start giving names to those composite widgets, the widgets which make up our widget. This is important because in a while we'll be using those names in C++, and the trick is we want to use in C++ things with the same name as what they've got in the widget blueprint, but we only care about naming things that we actually want to use in C++. I mean, you can name everything if you really want to, but it doesn't actually matter. So let's consider each widget that comprises our bar so far. The root widget, which is now a border, and we're going to want to set its color and transparency from a property in our widget. So we're going to need that. So I'll name that main border. Then there's the vertical box, which just does its job, hosting the rest of the components. As it stands, the C++ side of things doesn't really care about it, so we can ignore that for now. The scale box around the image widget, again, we don't need to do anything with that from C++, so we ignore it. The image widget inside, however, we will want to set the icon with its brush property, so we give it a name of icon image. The two border controls that we'll use to draw the actual bar, we obviously need those, so I name those %bar_empty and %bar_filled. The scale box around the text is similar to the one around the image. We can ignore it for now. And the text block itself, well, we're obviously going to want to play with that, so I'll name that one value text. Once again, we say little prayers to whichever deities we believe might hold influence over our project and click the Save All button, because blind faith is nice, but source control is better. Our work here is done, but instead of closing the editor and returning to the IDE as we might usually do, I'm going to leave the editor open in the background, because I want to refer to those names and what types of widget they are, and if I shut the editor down, I'm going to forget, type in the wrong thing, and then waste time fixing it later. So, back in Rider, I right-click the building blocks folder in the solution tree and add a new Unreal class. In the pop-up, I tell it I want to derive the new class from the UUserWidget base class we made earlier. For those Visual Studio users that feel that I'm not showing them enough love, I am really sorry. I'm juggling several projects right now, and there just isn't enough time for me to do everything in both IDEs. You can use the Add New Class wizard from the editor in the same way I've shown you previously if you're not using Rider or a Visual Studio setup that has an add-in that lets you do it easily. So, for the purposes of this tutorial, it's okay to make the class public, and so I choose that. I name the new class StatBarBase. The first thing we need to do is set up a property for each of the widgets in our derived widget that we're going to want to access. Yes, those are the things we just gave names to in the widget blueprint. If you forget how you name them or what classes they are, refer back to the editor. Both those things are in the top right hand corner to the right of the name. It's the class of the currently selected widget without the U in front of it. Remember to add that in your IDE. If you're doing things the newfangled UE5 way, which you probably are because it's unlikely you're following along with this video in UE4, you'll want to declare these properties as TObject pointers of the specified types. But if you do see any legacy code, you'll most likely see standard raw pointers being used. Now, Epic has made the TObject pointer to work pretty much as a drop-in replacement, their words, for raw pointers to UObject derived classes. And as it has been released as optional, at least for now, many people are just not going to use it unless you give them a good reason to. Firstly, when are we talking about using this? Well, it's for U properties. It's not for non-U property member variables, and it's not for local variables you define inside functions, for example in your CPP code. So, what's in it for me to actually use it, and how painful is it going to be to change over to using it, you ask? Well, as far as changing over, it's easy. You basically just say, instead of, in both those cases, I would, and generally do, initialize it to null pointer if I don't have an actual instance of something to initialize it to, as shown. Mostly, as far as your game goes, for the player at runtime in a shipping build, it does effectively nothing, and is pretty much the same as using the raw pointers we all used to use. However, in editor builds, it does various clever things relating to object references and lazy loading. This can mean you get a better experience in the editor with faster asset loading, a more effective usage of your system's memory. And some users have even reported it's improved their workflow when using blueprints, meaning that they no longer have to restart the editor after making certain changes. Eventually, Epic will more than likely make it mandatory for U properties. So bear that in mind. We probably should be conditioning ourselves to use it. If you've already amassed a great library of your own Unreal source code in C++, which kind of begs the question why you're watching a series for beginners, Epic have given us the Unreal Object Pointer tool, which can automatically replace all the raw pointers in your code with TObject pointer. So, while it is generally very useful to know specifically exactly what is happening under the hood, and while I'm generally not too comfortable with the just trust me bro approach, in this case, it is safe for you to basically say it's used the same as using a raw pointer to a UObject property, and Epic say it's the way to go, so I'll just roll with that for now. Note, when you are more comfortable with Unreal, probably after the massive success of your first major game, you can take a break from counting all the profits to see if you've cleared that $1 million threshold required before paying anything back to Epic, and return to this topic and read up on it properly. I'll put a link to the official Unreal documentation in the video description. Or you could just spend your time lazing on a sun-drenched beach, planning your next award-winning game, or building a secret lair in the center of a hollowed-out volcano. Whatever floats your boat. Anyway, with these properties, regardless of whether you declare them as raw pointers or use the TObject pointer, the special source, as far as widgets are concerned, is the meta specifier BindWidget. By having that in the property specifiers, you're telling Unreal that any blueprint class we base on this C++ class must have a constituent widget of the same type as that property with the same name. And you'll get blueprint compile errors if that's not the case. Once those properties are all set up, we can close the editor so we can cleanly do a build next time we want. In addition to these constituent widget properties, which incidentally are scoped as protected, I'm going to add some properties that we'll use to set various options for each bar. Through the magic of the U property specifiers, we can declare these as private, but use the edit anywhere specifier so that we can set values for them in the editor. A property called icon brush of type F slate brush allows us to specify what is displayed in the icon image widget at the top of the bar. A float called current percentage will be used to track the percentage value used to calculate the bar lengths, and another float called current value will track the actual amount displayed in the text at the bottom. Two F linear color properties will be used to set how the main border and the filled border brushes will look. And there's also a private F text called current value text, but that is not going to be exposed as a property as it doesn't need to be interacted with in the editor or serialized. Two public functions will allow us to hook this widget up to the delegates we created on the character in the previous video. OnIntStatUpdated and OnFloatStatUpdated cope with the two different sets of parameters we decided we wanted to support. Note that these are simply functions which have the same shape as the delegates we declared. They don't actually reference anything specifically in the character class, the delegate, declaration, or anything, and we don't really want them to. This widget might be used for basically any situation that warrants a StatBar widget of some kind, and it might not necessarily be anything to do with the character class. There's also two private functions. Process current value text is used to make an acceptable string from the current value. And it's a very naive piece of code, which I basically wrote off the top of my head, and it has a fairly ugly nested if statement. It does the job for what we need right now as a demonstration, but for a real project, I would move the entire function and place it in some kind of library somewhere, and rewrite it to properly be more performant and to cope with different ranges of numbers, levels of precision, and the way that different languages might display and format those numbers. The second private function is UpdateWidget, which is simply called by any function which causes the widget to be changed in some manner and require a redraw. A withEditor block is used in both the header and the CPP files to declare some overrides and provide code which will only be compiled into editor builds, as we discussed earlier. In this case, it's not doing anything particularly clever. It just allows us to be able to test how the bar looks when we change the percentage and value fields from inside the editor. Changing these in the editor has no real effect on how the widget operates at runtime. It's just there really to let us confirm that the widget actually functions in the way we want before trying to integrate it with the rest of the game. Okay, I realise that it might feel a bit like I'm bombarding you with so much stuff that it's a little hard to follow. Point of this video isn't really for you to be trying to follow along typing in code on your machine as you see me doing it in the video. That's why, unlike some of the earlier videos in the series, I'm not literally typing it out as we go. I've already written it beforehand and I'm just trying to walk you through what I did and explain what it's doing. Remember, download the full project and play around with it to see exactly what's what for yourself. Anyhow, let's just clarify what's going on and look at the actual implementation code for this StatBarBase class. So we set up those properties for the composite widgets with the BindWidget meta specifier. What that BindWidget thing actually does when you compile a blueprint derived from this C++ class, it looks for instances of the specific widgets in your blueprint, as I said before, with the same name and type, and it basically sets them as the value of those C++ properties for you. It binds the properties defined in C++ to the widgets you added in the blueprint. Oh right, BindWidget, I get it now. Anyway, let's take a look at the CPP code for that StatBarBase class. We'll cover each function in turn. Native onInitialized. This override gets called when the widget is initialized, unsurprisingly. Unfortunately, that in itself is still a little bit of a vague description. For now, just consider that it happens when the widget is started up. That means at runtime, when the game is playing, not in the editor. I use it here to call the UpdateWidget function to ensure that the widget looks how it should based on any property values that were set for it. Now let's look at the two withEditor functions, onDesignerChanged and post_editChange property. OnDesignerChanged is called whenever the widget is moved or resized in the designer, either because the user modified the widget directly or because they modified a container that the widget is in. Again, we just use this chance to call UpdateWidget to make sure that everything is redrawn correctly. We don't really need this. I just included it because it's often useful to know about if you want to make your widget behave properly in the editor under different circumstances. Post_editChange property is called whenever any of the widget's properties are changed in the editor. This is again a very useful place to call functions to update or modify your widget in specific ways based on which property was changed. For example, you might have a widget with an enum property allowing the user to select a value from a drop-down list in the editor. When they change that selected value, you might hide certain subwidgets, show others, or set the values of specific properties which will be used at runtime when the widget is displayed displayed to the player. In this case, I'm not doing anything clever or fancy here. I am just, once again, calling the UpdateWidget function. This means that when a user changes either the current percentage or current value properties in the editor, the widget will be automatically updated to reflect that change. Remember, that's not something which affects the widget at runtime in the actual game. It's just so we can see some changes in the editor, okay? So next are the functions onIntStatUpdated and onFloatStatUpdated. With these two functions, I'm showing a simple way we can support passing either integers or floats. All I do here is take the integer parameters passed to the int function, cast them to floats, and call the float version of the function. Yes, I know that might seem a little pointless or silly, and you may be wondering why I did that crazy nonsense back in the previous video anyway, with having functions for ints and floats. The main reason is quite simple. It's a tutorial. I intentionally did overcomplicate some areas to give me an opportunity to discuss certain things. We might do something like this, simply because we want to expose certain functionality to blueprints. In C++, we are free to have several different versions of a function, all with the same name, as long as they have different parameters. This is called function overloading, but it is not supported if we want to use ufunction blueprint callable to expose the function to blueprints. Another reason we might want to do something like this is when we really care about the data types we're using. We might select very appropriate data types in C++, chosen for their ability to store exactly the range of values we know we'll need, with the minimum storage overhead. You'll find out sooner or later that blueprints don't support most of the C++ data types. I'll come back to this topic again in part 7 when we look at modules, plugins and all that stuff, and we'll go over data types in C++ and how it affects blueprints. For now though, it's enough to know that the int version of the function just calls the float version. In the float version of the function, we calculate the actual percentage which will be used to set the bar height. Because we use the current value divided by the max value to calculate that, and we don't want any chance of getting a divide by zero error if for some reason the max value wasn't set correctly when the function was called, we check to see if it's exactly 0, and if so, we instead set it to what Unreal considers to be a small number. In fact, Epic have defined a value we can use, kinda_small_number, and it has a value which is 0.0001. And yes, that's kinda, as in a contraction of the words kind of. Now don't tell me that isn't the kind of naming that would feel right at home alongside classes called BindWidget. In fact, if English wasn't your first language and you googled kinda, you might end up thinking it was either a subspecies of baboon or an alien race from season 19 of Doctor Who. Baboon_small number? All we're really doing is taking the parameters, calculating the percentage, and then storing both that calculated percentage and the current value before calling UpdateWidget to modify the constituent widgets to display as we need them to. Process current value text. Basically, all this is doing is taking the float current value and formatting it as an ftext based on how big it is. Update widget. Okay, this is the money function as far as this widget is concerned. Because our percentage value is going to be either 1.0 or a fraction of 1.0, we use that to set the size of the border widgets in the slot that we saw earlier when we were designing in the widget editor. So the filled part should get a size equal to the current value, and the empty part should get a size equal to 1 minus that amount. In addition to that, we set the brush color for the background border and filled portion of the bar to the values we have in the properties. Note, if you wanted to be more optimal about performance, you might do things like that in a separate function, because you might argue that those things won't constantly change at runtime like the percentage in the value text. But you might also decide that you would let them change at runtime, like maybe have the bar flash different colors briefly in response to certain changes in values. It's your choice. Do whatever feels right for you. Okay, so all the remaining code just calls the process current value text function to get the ftext we'll use for the value and sets it on the composite widget. And finally, to cater for the widget being displayed in the minimal mode, we either show or collapse the %bars widget, which is holding the empty and full borders, meaning you either get to see them or you don't. So let's build it all. I slap that Control-B key combination, confident that my wonderful code will compile flawlessly. And, oh bum, it doesn't. I'm getting compile errors. But what could be the problem? Unresolved external symbol F slate brush. Well, in our race for power and glory, we forgot one small detail. We forgot to hook up the doll. No, we forgot to add dependency module names to the build.cs file because we're using Slate. We need Slate and Slate core. So I'll pop open the build.cs file and add those now. Okay, Control S to save everything, and a slightly less confident Control B to give another go at compiling. And this time, build succeeded. Wonderful. Let's fire this thing up and see what we have. Back in the editor, we can double-click the StatBarWidget blueprint to open it. Once it's open, we select the graph page and then the class settings. Using the parent class drop-down, we select StatBarBase. If we switch back to the designer page and then click the compile button, we will see if we correctly named our constituent widgets so that the C++ matches this blueprint. If we got it right, we shouldn't get any errors. If we didn't get it right, it will tell us that we don't have a widget of whatever type using whatever name, and then we can work out where we screwed up and fix it. This time, however, I got it right and there are no errors. Sweet. So we can save that and close it. Now we can open the HSP bar's standard widget again, and we can now select each of our 3 bars and have access to their properties. So in the testing category section, we can play with the values for both the percentage and the value, and we should see the shaded portion of the bar change and the text at the bottom change, respectively. Okay, so I can now select each bar and customize its properties, giving each the appropriate colors and a more relevant icon. Okay, still with me? Great. Let's take a moment just to review what we've done. We designed some widgets and how they might be laid out, generally speaking. We created a widget to represent the player's 3 main stats as 3 bars which are grouped together, the HSP bars. We created a widget to represent a single one of those bars, which will be used 3 times in that previous widget. We made C++ base classes for those widgets, and then in the editor, we reparented our blueprints so they derive from the C++ classes. Because we set things up so we can get the widget to provide feedback in the editor, we were able to do some minimal testing here, more of a confirmation of basic functionality than an actual test. And we were also able to provide meaningful values for some of the properties of the 3 instances of the bar widget which comprise our HSP widget, so that now it looks more like how we want it to appear in the game. So what's left to do? Well, for one thing, we want to get that HUD class set up so that it can actually display the different view modes we talked about earlier on and set up in that enumeration. And of course, we need to get our new HSP bar hooked up so that when we see it in the game, it actually responds to the player character stats changing. You'll be pleased to hear that those bits don't actually need a whole load of extra work. No, seriously, I've got them working in front of me right now. But this video has been rather long, so I'm going to bring it to a close here. I'd urge you to take a break, review what we covered, and maybe do something else for a little while. I'm reliably informed that regular people often go outside, and it's considered healthy. I tried it once, but I didn't see any improvement to either the speed at which my code compiled or its runtime performance. But whatever. Take care of yourself, and when you're ready, jump back into it with part B.